Here we are going to discuss the examples on the perpendicular axis theorem. So first I am taking a ring. Let's assume that there is a ring. There is a ring like this, right? And I want to find out the moment of inertia of this ring about its diameter. So it is the side view of this ring. If we look into the top view of this ring is something like this, right? This is the top view of this ring, and I want to find out the moment of inertia of this ring about a axis passing like this. Okay, I want to find out the moment of inertia about the diameter. Okay, so let's consider that this is x-axis, this is the y-axis, this is x-axis, this is y-axis, and there's the z-axis like this passing through the center of this ring, right? This is the z-axis. Now we know the moment of inertia about the z-axis. We can calculate it by the integration. And can you tell me what is the Iz? Iz is mr square for the ring, if you remember, right? And according to the perpendicular axis theorem, I can say that the Iz will be equal to Ix plus Iy. If you remember, that is the formula, right? So that is the equation of the perpendicular axis theorem. X and y should be in the plane of this body, right? So this is a planar body, and we can apply this perpendicular axis theorem, and x and y are in the plane, and the z is perpendicular to that, and all of them are passing through the same point. That's why I can say Iz equals to Ix plus Iy, right? Right now I am taking this is a uniform ring, where the mass of ring is m and the radius is r. So can you tell me, just think it, the moment of inertia about the x-axis and y-axis, will it be equal or not? Just think it. Okay, will it be equal? Why it should be equal? If the mass distribution and the perpendicular distance from the x-axis about the x-axis and about the y-axis are equal, then the moment of inertia should be equal, right? Okay, so I can say that because if I look about the x-axis and y-axis, the mass distribution is equal only. So that's why Ix is equal to Iy. And how do you know? By symmetry. We know that a uniform ring is symmetric about the diameter. Now I can say that Iz is equal to Ix plus Ix can be written down as 2Ix, right? So Ix will be Iz divided by 2. So that's why moment of inertia about the diameter, moment of inertia of ring about diameter will be Iz is mr square divided by 2. So this will be mr square divided by 2. Okay, what is important formula? You can even memorize this formula. Okay, right? Okay. Now let's take one more example. I'm taking now a disk. So this is a disk. This is a disk. Again, something like that. And this is the top view of this disk. This is top view of this disk. And again, I want to find out the moment of inertia about the diameter. Again, I will consider a x-axis and the y-axis passing through the plane of body. This is x-axis, this is y-axis, right? And this is the z-axis. Okay. Again, I can say from the perpendicular axis theorem that Iz will be equals to Ix will be equal to Ix plus Iy according to perpendicular axis theorem, and Iz is for the disk, you know about the about the axis which is perpendicular to the plane of disk and passing to the center of mass, the moment of inertia is mr square divided by 2. And by symmetry, I can say Ix equals to Iy. So in that case, Ix equals to Iy by symmetry. So then 2Ix will be equals to Iz, and that's why I about the diameter will be mr square divided by 2 is mr square divided by 4. So this is the moment of inertia